Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello and welcome. Thanks for coming to another episode of DevOps Accent. We are mkdev, where we provide DevOps, data, and AI consulting and engineering services. And here on DevOps Accents, we discuss all things related to our industry and anything that might get in our attention. And I hope I don't have to remind anyone to like and subscribe, but I still reminded you. Today, Pablo and Kirill have joined in to welcome our guest and a friend that we met during Italian Tech Weeks this year, Veronica Nigro. Hi, Veronica.
Hi, everyone. Nice to meet you guys. Thank you for inviting me here.
Nice to have you.
Nice to meet you. Hi, everyone.
So Veronica, she's a finance graduate who then turned data scientist with a focus on tech and AI. And in that role, she spent like 3 years in London startup scene before launching her own mkinf, a cloud platform that streamlines the development of AI agents and AI workloads. We will discuss this later. Now, Veronica, welcome to DevOps Accents. And speaking of accents, what is yours?
Well, I'm originally Italian. I'm not 100% sure if I do sound Italian. It might be a bit of a mix. Definitely some British influences here and there.
Yeah, I cannot say if it sounds Italian to me like 100%, but I definitely can hear some accents from the southern part of Europe.
Yeah, probably. It's a bit of a mix.
Thank you. This is another accent in our collection of DevOps accents. But speaking of your tech focus, where are you specialized in? Could you please give us a brief overview of how you started? Was it a choice for you, and how you get to the point where you currently are?
100%. So, well, as you mentioned, I am a finance graduate, but I've always, liked computers, like coding. So I not necessarily quickly, I diverged into programming. And in order to put together my finance background and coding, I started working into data science. So data science is my background, especially what is everything regarding machine learning and development. Right now, I feel like machine learning is almost like it's old. Like it's all like generative AI now. So, and it's not necessarily old, but what was NLP before it transitioned to large language models. Obviously, working with numbers, machine learning models are still super optimized and super great. But I kind of had to adapt to what was coming in the AI world. So from data scientist, still am. Well, now I am a co-founder of mkinf, but adapting to all the new Gen AI world.
I cannot help but ask, how does it feel being a woman in tech? Like you started and you you expressed your interest from the early years. How does it feel?
It's a lonely world. No, I'm kidding. But definitely more women are getting into this space, and I don't think it's necessarily really about like barriers. It's more like mental barriers. I feel like always people have been, this is more of a men's space. But if you are able to overcome this, I don't think it's necessarily too different. Maybe it's a bit of a controversial opinion, but I've always not necessarily really cared about if that place was for me or not. So
do you think the country you came from helped you with that? Fighting your way through the industry and making everyone around you be comfortable with I'm here, I'm staying, we have the same interest.
I mean, I cannot say Italy is the most forward-looking country. I did decide though so I was working in London, and then I wanted to find my own startup, and I wanted to do that in Italy, because I want to, foster this Italian startup ecosystem, even for obviously for women as well. So I'm not going to say I want to be an example, but I want to be part of this improvement.
And so we met at Italian Tech Week. Like a lot of startups, a lot of companies come to present their innovations, and you've been there with your own company. And I just wonder, at what point you decided that instead of doing something else, I won't do this, and why it was like specifically a decision to do this focus, to start in this area?
I met my co-founders, I think probably maybe a year before Tech Week, so we're relatively new, and we're both technical founders, so obviously passionate about this. We wanted to do something technical. We're a bit nerdy, and it all started because my co-founder Jonathan had I think 100 GPUs in his office, and he was using them for mining.
Naturally.
Then when mining naturally, he was literally warming up his office with those GPUs. Yeah, they were really cozy and warm in winter. But then when mining wasn't profitable anymore, they were just sitting there idle. And both coming from a technical background, so having worked with AI, and knowing the AI space, we thought there's a huge space right now for open for opportunity to do something with AI infrastructure and AI itself. So we actually built our first MVP on those GPUs, and then it obviously escalated to something else. But it all started from there, actually.
So, and you just decided let's not let these GPUs.
No, that's not. Yeah, initially it was we should probably sell them, obviously. And when you buy and sell a GPU online, it's like buying a car without knowing the mileage. There's no, yes, you can do benchmarking and certifications, but those marketplaces out there are not necessarily, the GPUs out there are not necessarily certified. So initially it was let's do a certified marketplace for GPUs. And then, with all the brainstorming that we did, it expanded from there to something else. There are, again, the market of GPUs is so inefficient right now. And so we started from there.
And for those who are not aware entirely about how GPU are used in cloud infrastructure, could you please give us an overview of the technology, how it's used, why it exists?
Yeah, of course. We can imagine GPUs as really powerful computer. Obviously, the comparison often is with CPUs. CPUs are designed for more general purpose computing, and the main difference is that they can handle a variety of tasks sequentially. GPUs, in contrast, they consist of thousands of smaller cores, and they're more optimized for parallel processing. So they can perform many calculations at the same time. So they can do that faster. They can do that in a more powerful way. And obviously, they are great for works that can be parallelized. So, for example, training an AI model, rendering 3D images, or analyzing large sets of data. So these are the loads of applications, but these are the main applications.
But we need to think that these GPUs, years ago, they were not made for machine learning or for, because it's something that these days the people is using to train models, something like that. But it was always created for video games.
Yeah, absolutely. As I mentioned, like rendering 3D images, but especially before, I think like any nerdy kid had probably like a GPU under their desk
Exactly.
To play video games. It definitely the applications were different, but they're still used for gaming as well. But as the AI world is developing, they found these are extremely powerful machines and they can be used for AI as well. So use cases not necessarily changed but expanded.
It's crazy how technology that 10 years ago was something different, now it's used and it's something like the most important thing in the world, because every company is they need GPUs. And for example, the thing that you are doing in mkinf, in your company, this idea to sharing the GPUs is something that the people need, because everyone needs GPUs these days. It's something like everyone need to have GPU access, but because of the price, not everyone is able to have all these machines at home. This is one of the main problems.
100%. And not only that, I think like there was like a couple of, still relevant now, but I think it was more like big news a couple of months ago of like this GPU scarcity. Obviously, Nvidia, which is like the main company producing these chips, releases new chips every couple of months, and then there's the problem of provisioning. But maybe it's like just my personal opinion, but I don't know. It's more like of a note, this GPU scarcity. I think it's more about resources that are not fully optimized and utilized, because even at like a data center level, so the GPUs generally sit into like data center, which is like super techy warehouses with cooling and all these GPUs sitting there. But obviously, you need to keep an inventory. You need to keep an inventory because GPUs might break, you might get a new client on board, and you want to you don't want to wait 6 months for Nvidia to give you GPUs. So lots of GPUs sitting idle at data center level. But even those that are contracted, for example, like long-term contracts, clients taking on doing these contracts of GPUs, you're not going to utilize all of them like 100% of the time. So there are lots of like inefficiencies in the GPU space. Yes, they might be scarce to find, but again, it's a lot more about tackling those inefficiencies.
Do you have to fight with misunderstandings and misconceptions about GPUs from the general audience? Because even I have this confusion. Probably that comes from the name. We have CPU, central process unit, and then GPU, graphical process unit. And like, okay, this device makes you work with graphics, but at the same time, we do not use GPUs for not only for graphical processing. This is something that we discovered as a byproduct of how GPUs were evolving for gaming, because you have to streamline textures, calculate geometry, shaders, things like that. And you have to put a lot of things into one processor, like that can do a lot of parallel things. And they named it graphical processor, but it's more like the same as with Viagra, right? They made a pill for heart, but then they discovered they have another side effects that help you perform better. And the same with GPUs, right? So we made it for graphics, but then we discovered, we can do so many other things, but we still call it a graphical processing unit. But do you think like we should rename it into something else to better reflect that what you are doing there? Because if you have to explain to your customer what you do, why they need this and the simplest way would be like, you need it for a lot of parallel tasks.
I get what you're saying. I'm not sure I'm in the position to change the name of GPUs, to be fair. they could definitely do maybe with better naming. Although the people that we talk to are generally technical, so they know that they need, it's a step further. They already know that they need GPUs for their workloads. The next the next thing they might not know is what kind of GPUs they need. So there are a lot of models, a lot of applications for GPUs, and a particular application may need more powerful GPU, less powerful GPU. Not necessarily about powerful, but like some, let's say, smaller and cheaper GPUs might be best optimized for certain type of tasks. And not everyone in the AI space, let's say, not everyone that does AI, deploy AI models, train models, is necessarily super familiar with AI infrastructure as well. So you need to understand the specific of the hardware, the specific of the memory as well, because you don't want to create a bottleneck into your process. So I think it's a bit of a, like a step further regarding GPUs.
Because even there are many types of GPUs. There are GPUs, general purpose GPUs for AI, GPUs for graphics. It's not only one kind of GPUs, because, for example, even there are generic GPUs like the one for Tesla that, you can use for general purpose. There are many of those, So it's not a simple question. I have a GPU. So I have GPUs and I need a specific GPU for this process.
Yes, 100%. And it's not only like, once you understand, what kind of GPU you need, how much memory you need, what's the whole infrastructure that you need, you also need to be able to, work with it and configure, in terms of like cost management and optimizations, for example. You want to have the best setup with scaling policies, for example, so that all your workloads and hardware is optimized in order to reduce idle time, for example. Or at some point, you once you train your models, you need to deploy these model and workloads. So it's a whole theme regarding the orchestration of GPUs, and these are tasks, let's say, specific for. There are a lot of different, positions in a technical team. I think I have emerged. So people that are in charge of usually in charge of dealing with this AI infrastructure are DevOps positions, and ML engineer, a software developer, a data scientist might not necessarily have the knowledge to deal with this infrastructure. And lots of startups that are emerging into this world, they might not have the resources to have all these positions. So I think the idea that we also want to tackle is to abstract all these infrastructure decisions, so that you don't. We don't want to replace DevOps. I think they have lots of stuff to work with, but this is like a simplifications into the workflow that could definitely be achieved.
You touch on an interesting part, because I was wondering, with all things that are kind of different and at the same time are kind of similar to traditional teams, cloud teams that we've been working at mkdev with, and some other unconventional, but there's still a difference. And can you describe a team or an individual engineer, what kind of skill they need to have to be able to maintain this kind of GPU cloud infrastructure? And this is a question to you guys, Pablo, Kirill, too. Is there a difference? Do we need to have some specific skills and some specific knowledge to be able to create this kind of infrastructure based on GPUs rather than CPUs?
If I get my point of view, you need this knowledge and this experience, because before it was a CPU. So, in most of the cases, nobody was taking care of that. It was, okay, depends on the machine, I have these kind of CPUs, but it wasn't so important. But these days, because of the price, that for me is the one that makes the difference. You need to consider what kind of GPU, and because of the amount of calculation that you need to generate, you need to reduce the times. And then, the price and the time, all those two parameters together made you that you need to choose the best GPU for you. But apart from that, at the end it's more or less similar to what it was before. Maybe I don't, Veronica, and you can.
No, I agree with Pablo. I think it's just about, extra knowledge that you need to acquire. And at the end of the day, that's time spent that you could be, doing something else, something more, if there's something that simplifies your life and you just need to learn how to do that, that's how it always worked. So you can, perform, other tasks, other things. So it's just about, acquiring and spending time, acquiring that knowledge.
But I think there is a difference in terms of, there's this whole field of MLOps. I think one of the biggest differences with what we usually do with CPUs is that there's a bigger chance that your software will mismatch with your hardware. And we had some cases with some of our customers that the same code would not just run in the same way, or the same training process would not run the same way on different GPU models. And I think there's also another dimension, and I'm not an expert, but so correct me if I'm wrong, that there is also two types of setups you can have. One is for basically training the model, then completely other kind of setup for inference. Then you need to configure them differently and also know what kind of hardware fits better for each of those use cases and set up infrastructure accordingly.
100%. There are two completely different use cases. And if we've been training models so far, now we need to obviously deploy them and inference in them. And it's a whole new different thing. So when you train a model, you want to have some specific type of hardware, but you also want to have it like all in one place for best performance. You probably want a different type of contract, so more like a long-term contract, because you know how long you're going to need those GPUs for. Whereas regarding inference, once you've done training a model, you want to distribute it, and distribution deployment means that the usage of GPUs is related to the user real-time usage. So you might have spikes in demand depending on the user interaction, and so like having, for example, long-term contract is probably not the best option anymore. You might want to set up some auto scaling, which is another skill that you need to acquire, and also you might need different machines. You want to understand how to best distribute them based on where your users are. So for example, you have like a user in Australia, you probably don't want to respond with a user that's in the US because of latency issues. So that's a whole new topic that people need to understand.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.
The name of the company, mkinf, implies artificial intelligence from the name, yes, because the inference, for those who doesn't know, it's the process of making AI model being able to draw conclusion from the data it didn't know before, something like that, if I understand it correctly. But even though the name of the company implies artificial intelligence use, do you think GPU-based infrastructure and in general, GPU can be utilized in other areas other than artificial intelligence? And how can the teams utilize them, use them for what kind of tasks? For example, I don't know, like scientific simulations or things like that. And what other areas a traditional or a conventional DevOps team might benefit from using the GPUs? in their processes?
Yeah, no, there are definitely loads of applications which one way or another always kind of like related to AI, I feel. You definitely mentioned scientific applications or simulations are, yes. So like fields like climate science, biomedical research, physics simulations, they often have to perform like complex simulations that require significant computational resources, and using like more traditional computing can, obviously will take more time. So GPUs are probably like a better use case for these kind of simulations, but also in the, I don't say creative, but like more visual space. So for example, like real-time video and image processing, so applications that require real-time processing of video and image data, like autonomous driving or facial recognition, augmented reality, something that I think people might be more not necessarily like familiar with when you watch like a football match and you have the replays of the schemas of what the football players did. This is all like augmented reality that needs to happen like real time, and that's like another applications, for example.
So you're saying that whenever I see these, we've been watching Olympics not long ago, when they have all these graphics on top of and you're saying that in order to correctly produce all these graphics, all this computation, they have to use GPUs in the environment, in the setups?
Yeah, 100%. It's like for format conversion, compression, and you need to apply the real-time effects. You need a powerful machine underneath, and the moment this is what delivers the best.
I didn't think about that because I thought that it's just when you have a lot of data, like a lot of database operations, and you have to calculate a lot of things at the same time and not spend a lot of time. You have to refocus from CPU to GPU, and basically that's it.
It's definitely all about data, but like when you think about images and videos, despite you thinking, oh, well, it's only one image or one video, that's a lot, like tons of data within that frame.
Like if you have an advice for the teams, like at what point they can understand that they need to switch from traditional cloud providers and activate options from that cloud providers, switch to you or to other platforms. How can they understand that they do not have enough, power or capacity with traditional setup, but they need to consider adding GPUs? If this question even make any sense?
No, I get it. I think it's not necessarily about understanding when you need like a different solution. I think it all starts from like a pain. So, like obviously when you have like a pain or a problem, you look elsewhere for solutions and try not to be stuck in what you currently use. The pains, like people might turn to our platform because of the pains and the problems they might have on other cloud solutions that they're currently be using. So what we want to, well, first of all, we are vertical on AI. So there are other solutions, like for example AWS, GCP, Azure. They're a great platform, they have so many products, but they're also extremely complicated to use. And if you want to perform that specific task and you're just starting out as a company, or you just want to maintain your structure like very lean, you don't want to deal with all those decisions of like setting up an infrastructure, and you might just simply want to have machines just when you need. So maybe not be locked into like long-term contracts, but you want to be able to switch on and off your machines like by the minute, for example. Or you want to be able to scale your machines from 0 to 100 and back to 0 within minutes because of your real-time usage. These are not something that we convince people to do. It's just simply they are born from their needs and their problems that they're encountering, and this is what we want to tackle. So the whole abstraction of those decisions, but not just infrastructure decisions, also workflows within AI, and particularly the development of AI agents, which I think is the next step in AI. Many companies now, this more generalist model are not necessarily the right solution for them. They want agents that are more specific, that adapt to the information that they are provided, and again, they want to be able to create them, and not necessarily just from scratch. So AI agents are built from tools that at the moment are probably all scattered everywhere on GitHub. So they're just like pieces of code that I think could like totally be reusable. But we're seeing now like maybe like libraries of tools being born, but I don't think there's like a single place where you're like, I want to create an AI agent and I want to do it in like an easy way, and then I want to deploy on an infrastructure that can actually support this workload. So this is what we're aiming for, and I think will be the next step in AI.
Because what you are offering is a simple way to get access to the GPUs, no?
Yeah, it's a simple way to interface with GPUs, but at some point, like we keep adding layers. So obviously, even those cloud providers, yes, they do often like give you like a raw GPU, but we keep adding layers in order to simplify the interaction with these machines. So it's like software on top of these GPUs, and then like simply the tokenization of models, so you can actually fine tune and utilize those models on top of the GPUs, and you almost forget that there's actually a GPU running underneath. And then the next step, again, AI agents. So we're keeping we keep adding layers to abstract all those infrastructure decisions, but at the end of the day, the infrastructure underneath, needs to be solid and flexible and scalable to be able to do that.
The only problem that I can see in this business, is that you have three competitors that are like three monsters. So you are David against Goliath, But
100%. I don't necessarily see them as competitive. Like I don't. I think that just have different use cases, and the data center. So how do we build our capacity? The data center space is literally people are pouring money into it, and you have the three big giants, the three big hyperscalers that you mentioned. But with all these investments, we are pretty much creating like silos of data centers being created here and there. And in order to utilize them, first of all, they want to focus on their hardware, having the latest hardware, focusing on ESG metrics. So they are not building products optimized for AI. That's a thing. And then they're all extremely different. So if you want like a more complete offering, taking GPUs from here and GPUs from there, you need to deal with different APIs, different protocols, different contracts. So what we're doing is is standardizing the access to all these independent data centers, which can they're more like the underdogs in this space, but can also, they give you extremely powerful machines with certifications and everything, but like at a fraction of the cost. So we are standardizing this access and pretty much creating like a GPU pool, kind of like an energy grid, but like a compute grid, we call it, where people can, share resources, take GPUs and put them on the grid. But also the idea was always to create this solid ground to build something on top optimized for AI. So now that we have this pool of GPUs, which is scalable, it's flexible, you can take machines by the minute and stop them whenever you want. But the idea is not to just give you like a raw machine, but to give you a simplified way to work with it.
The good thing when I meet you, in Torino, for me, there are many companies these days that I meet, weekly or daily. I talk with companies every day. And you see many companies that you think, okay, man, so you had to do that 3 years ago, because now there are, the time It's not now. Oh, maybe in 3 years this is going to work, but not now because what you're doing is super advanced. But the good thing is that I think that what you're doing in Make Inference is exactly in the moment, because as you were telling, the agents is something that is going to explode in the next year. You know, in 2025 or 2026 is something that everyone is going to be using agents. And I think that the cool thing is that you're exactly in the moment when you need to do something. And this is fantastic, you know, because it's something good for you too. So for you three, you know, it's something that is going to work, and it's something that is going to be, you know, I think very good for you.
Oh, thank you, Pablo. I really hope we we are ahead of the time. I'm not sure if we really are, because definitely AI agents are something that is happening right now. But we with the tech space, you always trying to not necessarily anticipate, but you need to be really ahead of the wave that's coming in order to be appealing for the space. So yeah, fingers crossed we're able to do that.
But with hyperscalers, right? You can always, if you look at AWS, they basically released something like AWS Lambda, this ultimate way to abstract running applications a decade ago. And it never stopped, let's say, Flyo and Vercel and similar platform as a service companies to offer something way better. And they're now huge, each of this. So they just managed to provide a better service and abstractions than hyperscalers, like better than Cloud Run, better than Fargate and Lambda. And I think in the AI space is also the moment when, for sure, they're also building, like AWS and Google, they're also building similar things. But I always feel like they play in a catch-up game and just trying to see what is hyped in the market. And with the right approach, if you just build from scratch something focused on these use cases, that's for sure will be needed. Plus, if you compare all the benchmarks of what currently hyperscalers are offering in terms of a GPU, they are almost never winning in terms of the speed of inference, because then they have all these layers that they built over the years with hardwares and virtual machines, etc. And also in the price, they are almost always more expensive than more focused and scoped infrastructure providers.
Yeah, no, 100%. I feel this is why we're doing this. I feel this is a problem that people feel right now, and different startups are trying to tackle in different ways. And we just hope that just what we're doing is one of the right ways that we can do this.
Yeah, speaking of the price, I think this is a very important part for the startups, for scale-ups, and for the companies who've been on the market for a long time. I mean, a large enterprises, when they consider creating something like that, or they're creating a new feature or a new application, they might consider the providers they've been working for many years. But when it comes to new companies, and when they're choosing who to work with, working with a company that at the same market, at the same stage, and evolving and developing alongside with you, more lean and easy to move and easy to adjust to my demands at this very moment is most preferable. But the part about the price is an interesting part, how the cost management works with GPUs compared to how it works with CPUs, because especially when you say that you can basically rent it per minute and it runs and stops on demand, because you have this rack of GPUs and you have to manage which of these is working, or do they work. My question is for the cost part from your side, how can you manage those costs for the companies, depending on how you make your GPUs running all the time? How you have to pay your bills on electricity, on a lot of computational energy that you spend, or you have to optimize your GPU usage on your own side to be able to provide more optimized costs for the users.
All right, so definitely this topic of cost management for GPUs is definitely super hot, and for mainly one reason. GPUs are very expensive, and despite like you're saying, they go between $5 and $4 an hour, and you think, well, it's not that much. But it's the units that you need to consider. So it's like one GPU, and then it's like one, even if it's like $1 per hour, but you might need like 100, and that's already like $100 per hour. And then you might need for X amount of hours per month, and then you end up spending thousands of dollars per month, even if it just started with like $1 per hour. So this is something that companies definitely want to consider and look out for, and look for other solutions that can help them optimize these costs. And it obviously all starts based on what kind of job or workload you need to run. So we were talking about this before. For training, you probably want like a more long-term contracts, and they're definitely, longer term contracts are definitely cheaper than taking machines like on the spot or on demand. But when the most prominent use cases are obviously inferencing and using those models, you want to be able to pay for exactly what you used your machines for, and you want to be able to monitor that usage, but you also don't want to deal with it. So you have, let's say you have 10 GPUs that you're using, and then you might need more, you might need 20, and then you don't want to say, oh, I need 10 more, and then you want to scale back to 0. So you want a system that is able to auto scale the number of GPUs that you're using and switch them off when you're not using them. Another thing is probably having to do with the data that you're running on those machines. So some setups that allow you for GPU sharing, for example, but obviously that's for use cases where the data, the sensitivity of the data is not necessarily like a problem, and you can obviously save on that as well. And then, well, if we dig deeper, there are other optimizations that you can perform. So, for example, you can optimize the workloads in order to, let's say, reduce memory usage without necessarily compromising accuracy, or you can other things. You can schedule non-urgent jobs during off-peak hours, so you can like schedule when to do that particular job, these are things that we that I think are necessary to do. But also, sorry, one last thing. I mentioned it before. You have like a long-term contract, and you have GPUs sitting idle, for example. We want to enable that kind of like reselling, or like that usage of GPUs from other companies when you're not using them. And this is all to tackle so-called GPU scarcity. But again, it's just a bad management and allocation.
To me, this sounds super complicated. And is it something that needs to be considered on your customer side, or is it something that you consider and offer them a better options, a better flexibility, so that they do not have to think about it? Because when I imagine myself in the position of a manager of the infrastructure, and I have to calculate the costs, and I have to calculate the workload that I need to spread depending on whatever needs, this sounds like a nightmare. How is it even possible to?
No. It absolutely is a nightmare, and this is why we're offering this solution. We don't want, people have these problems, and we want to take these problems away from them. So we don't want them to deal with like the scaling, with the switching off the machines when they're not being used, with again, for the over provisioning, or even picking what's the right GPU for the workload that they need to do. We just want them to tell us, okay, I'm running this thing. What's the best setup that you can provide for me? And we might provide, different packages. Okay, so this is the fastest. This is like cost optimized, but you don't really have to make any necessarily any decisions or acquire any knowledge to work with our system.
And is there a difference in deploying GPUs in public or hybrid multi-cloud setups. In cost management and cost optimization strategies.
Well, definitely. So at the beginning of the year, I think it's just being implemented. The EU Data Act removed the egress cost from AWS, GCP, etc. So what are egress costs? Before you had to pay to take data out of those platforms. And so it was like a bit of an oligopoly. Like once you had data on like AWS, it was too expensive to take it out. And so not many other alternatives were really possible. With the removal of this cost, different solutions emerged. So you might still have, your long-term contract on AWS, but you might use another provider, so more hybrid usage of clouds in order to minimize your cost, because that other platform might be best for that specific task and it's actually cheaper, etc. So this definitely made this process faster.
I wanted to Pablo just touched a little bit on that, on the next year's 2025, 2026. I just wonder, how do you think this will evolve in the future? Because to me, this is always my questions for the industry, for personal computer industry, because I know that GPUs, they work faster and better in general, and I was thinking, why we just don't switch to GPUs for all the tasks? I'm thinking like that. Even though the basic and obvious answer is power management and the amount of energy that GPU consumes. But at the same time, when I look at my desktop, I can see how even sometimes coolers stop spinning on it because it starts to consume less energy. It doesn't produce a lot of heating, and it doesn't need to cool it down, so it stops. So I was just wondering why we can't apply the same technique to anything and just use GPUs. And so I think my question is, do you think this industry will evolve faster than we expect because of the amount of tasks that we direct from CPUs to GPUs and the amount of computational power that is required? We've been discussing a report recently and how even Google or other companies, they opt out from their environmental goals of reducing their carbon footprint because they realize that with emerging AIs, as the amount of power, the computational power they're using, they create much more carbon gas that they before. And how will it change in next years? Will it become a trend?
Tough question. Because as you mentioned, this is a space that it's not going to move quickly. It already moves way too fast. So the only thing you can do is pretty much being able to adapt as fast. And again, I'm not. You mentioned, Pablo, AI agents are going to be something of the future, but I think it's already happening. It's like once you say, it's already happening. So you need to be able to adapt. And what we want to build is something that is also able to adapt as fast. So we mentioned before, there's all infrastructure of GPUs, but we're actually GPU agnostic. So we're not only taking, NVIDIA right now is like the main producer of these chips. But there are many other players right now that are producing their own chips, and they're more optimized for other specific tasks. So definitely being able to integrate all these other GPUs and have like a more complete offering will make us more flexible and more ready for what's going to come ahead. But also, having this infrastructure which is flexible, scalable, and you can build pretty much anything on top related to AI makes us quick to adapt to anything that might come, I think. We're not tied in with like any crazy contracts or anything. So I think it's all about, this is a space that moves very fast and you need to adapt even faster. So it all comes down to that.
And the good thing is that when you go to these events, everyone is using something with AI. There are companies creating AI, but there are companies adding AI to what it was before. So at the end, you don't need to find customers. Everyone is your customer. So no, this is the good thing, because for example, if you are selling meat, oh no, man, sorry, I'm vegetarian. But in this moment, everyone is eating meat. So it's simple to go with your cow and offer meat to everyone, because I think this is the best moment for this kind of solution, because you never know what could happen in 2 years. So, and this is as I was telling before, this is the moment to cut the cow in pieces and start to sell the cow, because everyone wants to use GPUs. Is the moment.
But talking about next 2 years, what I was thinking is that how happened with the regular software, right? It used to be that we run all of our software on our computers directly till we kind of move to this web world where you have email client in the browser, podcast recording in the browser, everything. So now, and that's what cloud enabled, right? Because you have a bigger compute capacity in the cloud. So now we moved lots of our software to run somewhere else in the cloud. And it's curious thing, because with AI, it moves a bit in a different direction, right? Because we are now in this world where all of the AI stuff runs in the cloud. But what we see in like this year, that there are more and more generative models that can be run on your device directly. So now, of course, with biggest one now is Apple Intelligence, and with their chips that now allow you to run basically LLMs and like creating images and many other things directly on your device. Do you see, because the chips will improve further, we'll get like 2 nanometer chips, maybe like in 1-2 years, we'll have even more powerful GPUs directly in our pockets and the laptops. Do you think these kind of personal devices will eat a big share of cloud market for AI, or will it kind of still be primarily in the cloud?
I think no. I think the market, the space is definitely moving towards, well, definitely closer to the users. So we're seeing like urban data centers, or like smaller data, especially because of like the huge amount, they use a huge amount of energy. So this is probably something that it needed to happen anyway. Like smaller, more distributed data centers. So we're definitely getting closer to the users. The next step is like after there's urban data centers, or like a smaller data center distributor, is probably going to be GPUs or computing directly on your device. I don't have a time frame for that, because at the moment GPUs are like this big at the moment, and then they need to fit into your hardware. And even if I might say it might take at least 5 years, it moves so quickly that it could happen next year. I have no idea. So yeah.
And another thing that concerns me as a gamer, do you think that tasks like yours steal resources that NVIDIA and other GPU providers steal from gaming to your tasks? Like, for example, they're announcing basically the last question. They're announcing 590, 5090, okay, RTX 5090 soon. And do you think they consider your needs first rather than gaming needs?
Tough question. Well, definitely the gaming industry is huge. I think it'll be, rather than necessarily saying more focus on gaming, I think the gaming will shift more towards the AI. I've seen some things that like the game is produced like almost like real time with the AI underneath, like with the rendering is like produced real time based on the user interaction. Actually, I have no idea how it works, but I think it's going to be more the gaming shifting towards AI and the chips following along.
Cool. Thank you. Thank you for this overview of the future, and thank you for introductions to GPU area. This is very interesting, and I hope this was very interesting for our listeners too, and for you as well. Thanks for coming. Thanks for joining us. And thanks you for sharing. And those who listens to us, we will see you in 2 weeks. Thank you. And bye, everyone.
Thank you, guys. Bye.
Thanks so much. Bye-bye.
Bye.
Do you think your project infrastructure is well set and maintained? We know for sure there is always room for improvement. If you are uncertain where to begin, let's first do an audit of what you already have. We will review your setup from every angle: performance, cost, security, high availability, and automation, and provide you with a detailed roadmap of which direction your infrastructure should go, generate concrete tasks for you to implement, or even take on your infra entirely, if you let us, of course.